You're listening to the Nutrition Experts Podcast, featuring guests who take the scientific talk about food and break it down for practical use. You've heard the phrase, "You are what you eat." Come find out what that really means. Experience conversations with experts in the field of nutrition and understand the power of food for our health, well-being, and beyond. Now, here's your host, registered dietitian and nutritionist, Mathea Ford.
Hi there, it's Mathea. Welcome back to the Nutrition Experts Podcast, the podcast featuring nutrition experts who are leading the way using food. Starts today, right now, with our next guest. It's great to have Sangeeta Pradhan on the show today. Sangeeta, welcome to Nutrition Experts.
Thank you so much, Mathea. I'm so excited to be on your show.
Well, I'm excited to have you on the show and share your expertise about the brain and the human brain and how it works with my tribe today. So tell my listeners a little more about you and what you do besides this brain research stuff too.
So I am a registered dietitian and a certified diabetes educator. I am the diabetes program coordinator for a physician practice group in Metro West, Massachusetts. I happen to be the chair of the Central Mass Dietetic Association. I also do a lot of community outreach projects and present at professional conferences, speaking at conferences or in my community groups is something that I really enjoy doing because I think it gives us a wonderful platform to really put out the word about nutrition without the hype. So that's something I really enjoy doing. So I do various community projects ranging from presentations to workshops, occasionally food demonstrations. I'm also a guest blogger for the Academy of Nutrition and Dietetics Stone Soup magazine. And I also have my own personal blog. When I'm not doing any of those, you'll probably find me in my kitchen cooking up a storm and developing recipes, which subsequently I post on my blog.
Great. I love that you do so many different things and you're kind of connected with your community, because I think that's where we kind of get a lot of our inspiration as dietitians is from our patients, from the people we work with. So I know you've done research on the human brain and how it relates with nutrition, with cognitive function. And I think it's transformative information that we're going to talk about today. So what makes that so exciting?
Yeah, Mathea, I'm really excited to be presenting on how nutrition impacts cognitive function. So brain research is evolving at a mind-blowing pace, no pun intended, and is one of the most exciting frontiers in medicine today. We now know that our brain is not static and hardwired as previously thought, but this dynamic organ where new neurons and new neural connections are created every day, regardless of your age. Up until the 1990s, it was mistakenly believed that our brain was static and that we did not grow new neurons at all. Well, turns out nothing could be farther from the truth. And modifiable lifestyle factors, i.e. diet and lifestyle, can profoundly influence this whole process and indeed the course of neurological disorders and cognitive function itself. What is truly transformative about this research is that in a phenomenon called neuroplasticity, we can actually change our brains for the better. So that begs the question, can we use simple biohacks such as the food we eat or our ability to take a walk to upgrade our brain to the best version of itself? And the answer is yes. And that really is the crux of our discussion today. And I hope to get that message across to your audience.
Okay, so can you talk about how our brains work? Talk about how our brains create new connections?
Our brains are incredibly, amazingly complex. So how the brain works is a very broad question. But what I would like to do is narrow it down to how the neurons work and communicate with each other in the context of what we are discussing today, which is neuroplasticity and neurogenesis, and how does food fit into that picture. We've all heard of neurons, which are basically brain cells. The brain is part of the central nervous system, which consists of the brain and the spinal cord. And the neurons communicate with each other through chemical and electrical signals. So let me just explain that a little bit. When a neuron transmits a signal to its neighboring neuron, it's actually an electrical signal that gets transmitted. And there is this little gap between the two neurons, and it's called a synapse. It's very microscopic. It's really, really tiny. It's like 1,000th the width of a hair. So you can imagine how microscopic it is. So this electric signal travels down what we would call the presynaptic neuron. That's the neuron that's emitting the message. But that electric signal cannot just jump across the synaptic cleft. It has to be converted into a chemical impulse, which we all know as a neurotransmitter. So this neurotransmitter then drifts across the synaptic cleft, latches on to the postsynaptic neuron, which is the neuron that's receiving the signal. And in so doing, it stimulates it. And this is how neurons communicate. And when these neurons connect with other neurons through their synapses, they form complex neural networks that are responsible for all of the brain's functions. Your next question, I think, was talk about how brains create new connections. Is that what your next question was?
Yes. Can you talk about, you talked a little bit about, well, not about how brains create new connections, but yeah, tell us a little bit about how, you said neuroplasticity a little bit, and we'll talk about that in a minute, but tell us about how our brains create new connections, because you said we're always changing, always growing.
Exactly. This process by which the brain creates new connections is called neurogenesis. Neurons, genesis, the birth of new neurons. In this context, I would like to introduce a term called neurotrophin. So neurons, trophins, are basically proteins in the brain that allow fragile new neurons to grow and survive and proliferate. Now, in case your listeners are wondering, why would new neurons not survive? Well, we have to bear in mind that we are living in a highly neurotoxic world, and our bodies are under constant siege, if you will, by free radicals that are created from oxidative stress in our environment, or from pollution, the foods we eat, the metabolic processes in the body. As a result of this, these fragile new neurons created from brain cells do not survive unless we have an adequate amount of these neurotrophins. So you want to think about neurotrophins almost like a protective mother taking care of her little ones and creating a nurturing environment for them. So not only do these neurotrophins allow these little neurons to survive, more importantly, these neurotrophins allow and enable these neurons to connect with each other through their synapses and to wire together. And it is this wiring of neural networks that allows the formation and consolidation of memory. This is how we learn. This is what promotes higher thinking. So we have these wonderful neural connections and we can grow new neurons every day. However, the rates of neurogenesis vary from individual to individual. And this is where we can use modifiable lifestyle factors, diet and exercise, to influence this process, which makes it very exciting and very empowering.
So when people say that, for example, drinking beer kills brain cells, it really can, because it's going to create those free radicals that attack the brain, the new neurons, right?
Exactly. So it could be a food entity. It could be something in the environment, anything that causes oxidative stress and creates free radicals, which, for the benefit of the audience, I just want to explain. Free radicals are simply lone oxygen atoms. We think of oxygen as being beneficial, and of course it is. But when a free radical is created, you have this lone oxygen atom that is missing an electron, and that makes it highly unstable, very reactive, and it begins to strip electrons from different compounds in your body. The loss of an electron creates oxidation, oxidative damage, and these free radicals can wreak havoc in the body. So to your point, yes, excess amounts of certain foods, such as refined carbohydrates or high-fat foods or beer and so forth, can cause oxidative damage in the body. But we can counteract that by eating healthy foods. That's the whole crux of the discussion.
Are we going to talk about how do you create more neurotrophins? Or is that something that you can tell us a little bit more? Because I'm intrigued by this idea of neurotrophins being like moms protecting new brain cells. How do we get more of those in our brain?
Absolutely. So I think in this context, again, I want to introduce a molecule known as brain-derived neurotrophic factor. So it's simply a nerve growth factor. It is a neurotrophin, but the reason why I'm bringing that into the discussion now is because brain-derived neurotrophic factor is the star of the show. A lot of experts refer to it as miracle grow for the brain. Isn't that something? So yeah, pretty mind-blowing. What the research shows is that a typical Western diet that is high in saturated fat and high in animal protein and high in refined carbs and added sugars literally drops levels of BDNF, or brain-derived neurotrophic factor, in the brain. So if you have fewer of these neurotrophins, highly protective neurotrophins, bearing in mind that they allow the little neurons to survive and grow and connect and form synaptic connections, there's less of those connections now. But since it's the wiring of neural networks that leads to the formation and consolidation of memory, new memories are not formed. And in fact, this is exactly what happens to folks with dementia and Alzheimer's disease. No new neurons are produced in a structure of the brain known as the hippocampus. The hippocampus is actually a part of the limbic system. You could call it the central command in the brain for memory and higher thinking. So when BDNF levels drop and no new neurons are produced, no new memories are formed. So people with Alzheimer's, for instance, might remember something that they did 20 years ago, but their short-term memory is lost because they don't form new memories, and they end up becoming sort of a shadow, if you will, of their former selves. So by eating foods with antioxidant potential, what you can do is you can combat some of the oxidative stress that causes the body to lose some of those neurotrophins. You can combat that oxidative stress and boost back BDNF levels. And in so doing, you promote cognitive function again.
You mentioned that people with Alzheimer's dementia aren't building new tissues and connection. Is there, I think I've always thought, or always, maybe I just had this thought, but that there's an age where we kind of stop getting new brain cells, where we stop making tissues and connections. Is that true?
Actually, the research, which is really exciting, shows that that is not true, which is truly staggering. There is no age where we stop making new neurons. How exciting is that?
That is, because that means obviously you can continue to have good brain health throughout your life.
Right. So there was a study I think it was a 2013 study in the journal Cell that showed that even into our old age, we can create 700 new neurons every day. Now, bear in mind that we have like 86 to 100 billion neurons, and they form thousands of synaptic connections. So 700 might seem like a drop in the bucket, but the fact that we are actually creating new neurons in itself is very valuable. So yes, we can continue to build new neurons into our old age, but as I said, the rates of neurogenesis can vary. And this is where I think we can use the power of neurogenesis through foods and lifestyle to positively influence that process.
So you mentioned before neuroplasticity. So let's go back to that. What is neuroplasticity specifically, and how is it discovered?
In very broad terms, neuroplasticity is the ability of the brain to adapt and change and rewire itself and reorganize itself in response to our experiences. Our brain is incredibly moldable, and every thought, think about this, every thought, every emotion, every experience we undergo changes the brain for the better or worse. So it's pretty amazing. You asked, how was it discovered? So the history of neuroplasticity, believe it or not, goes back to the 1890s, when William James, in his book, talked about it. He said that the brain was plastic, but at that time, the concept did not really take hold. It wasn't until the 1950s that they did an experiment with rats. So I do want to mention that this cognitive science and this whole research is relatively new. It's emerging research. A lot of the research has been done in animal models. We do need more randomized clinical trials, but what we have seen so far is pretty compelling. Anyway, to go back to the 1950s, they did this experiment in 2 sets of rats, and one set of rats was placed in an enriched social environment where they were basically, they were given rat toys, they were allowed to interact with their little rat buddies, they were made to run on running wheels, and then they had another set of rats where the poor little critters were isolated from each other, they didn't have their little buddies to play with, and so forth. And what they observed was that the rats in the enriched social environment had higher rates of neurogenesis, and they had more synaptic connections, those connections that we were talking about earlier. So that was sort of a breakthrough research that they stumbled upon in the 1950s. And then later, more research was done in the 1970s. But again, it wasn't until the late 1990s that we discovered that we can actually grow new neurons.
We've talked about neurogenesis and neuroplasticity. Is there a link between neuroplasticity and like the habits that we form? So does one, being able to change our brain, being able to move it, create new memories, does that help with habits, or is that any at all related?
So to really get an understanding of how that works, Mathea, I'm going to take us back to what I was talking about very earlier on in our podcast today. If you recall, we were talking about how the neurons connect to each other through their synapses, and the neurotransmitter travels the synaptic cleft and so on and so forth, and the signal is transmitted. So what the research shows is that repeated signals and high frequency signals strengthen synaptic connections in a process called long-term potentiation, or the audience can just think about it as long-term memory to keep this simple. Repeated signals strengthen synaptic connections, and the opposite is true, so that weak signals will weaken a synaptic connection. You want to think about your brain like a power grid with these complex neural circuits going zzz. We can just imagine how it's all working, right? So when you engage in a particular behavior, that neural pathway in the grid lights up. When you keep repeating that behavior, those neurons become more and more excitable, and it gets easier and easier for the brain to use that particular pathway. Neuroplasticity follows the use it or lose it rule. Frequently used synaptic connections and neural pathways get stronger and stronger, and the pathways that are infrequently used or seldom used will weaken and disappear over time. And this is called synaptic pruning, which I thought was very apt. Your body says, your brain says, hey, you're not using this memory, I'm going to snip it off. Just like you would prune excess branches, if you will, in the shrubs in your yard that you don't need. But a memory that's revisited over and over again, the brain says, hey, I guess you need it, so I'm going to hold on to it. That synapse, that synaptic connection has strengthened over time. Let me share another example. In high school, if you hated calculus like I did, but you loved history, I remember rattling off historical events at the drop of a hat because I kept reviewing history notes. But speaking for myself, I nearly flunked calculus. That's because the synapses associated with calculus weakened over time because I didn't pay any attention. But I kept reviewing history notes, almost became the teacher's pet, because those synapses got stronger and stronger. The use it or lose it rule. We can use neuroplasticity to actually develop better habits and give up the ones that are not working for us. So drug addiction, for instance, is the darker side of neuroplasticity. But you can see how you can tap into the power of neuroplasticity to engage and develop habits that work in our favor, if that makes sense.
So is that where the idea has come from, that it takes 21 days to develop a new habit, even though we know it's not necessarily 21 days specifically, but you have to give your brain that repeated stimulus?
You know, again, the expression practice makes perfect. It just puts that into a whole new perspective, doesn't it?
Yeah, your brain's practicing and your body is practicing doing whatever. So let's talk a little bit, let's get more into the nutrition side since we're both dietitians. We talked about what causes the brain to have neuroplasticity, but what foods have been studied that can affect our brains?
So a whole array of foods have been studied, but in a very broad sense, let's talk about the big picture first. What they have seen is that the Western diet that we just referred to a little earlier on in the podcast, that is high in processed foods and high saturated fat foods and high in sugar and whatnot. What they have seen is that it actually literally shrinks the hippocampus. It's called hippocampus atrophy. The hippocampus, which is the part of the brain, which, as I said, is command central for memory and learning, literally shrinks with the Western diet. And also BDNF levels, not surprisingly, drop with the Western diet. So basically, lower intake of nutrient-dense foods and higher intakes of unhealthy foods can cause that hippocampus to shrink and have also been associated with increased risk of depression and cognitive decline. So that's sort of in a broader sense. But in terms of specific nutrients that have been investigated, DHA, an omega-3 fatty acid, it's a 22 carbon, I believe, omega-3 fatty acid. It's found in fish oils, found in walnuts, found in seeds like flaxseed, chia seeds, and so forth. So DHA is actually an integral component of neuronal cell membranes. You know, a good analogy I can give, well, I hope it's a good analogy, is if you're thinking about constructing a building, you would want high quality building materials. So also if you want to build a good brain, you need good amounts of these omega-3 fatty acids. So DHA has been investigated. Here's the catch. While prospective studies have shown that, for instance, just eating one fatty fish meal a week can reduce your risk of Alzheimer's by 60%, randomized clinical trials with 2 grams of algal DHA have been somewhat disappointing. That said, I would still encourage your audience to include fatty fish and omega-3 fatty acids, because ultimately, at the end of the day, it's really the whole foods that count and whole dietary patterns that count. We don't want to get too hung up on isolated nutrients. So that's the scoop on DHA. And then there's curcumin, which is the active extract of turmeric. And that also we know it has antioxidant, anti-inflammatory properties. But again, in clinical trials, the results have been somewhat mixed. So there was this 24-week placebo-controlled trial. There were, I think, 36 subjects enrolled in the trial. So it was a relatively small trial. And they were randomized to placebo or 2 grams a day of curcumin or 4 grams a day, and it failed to demonstrate any efficacy. But again, I just want to caution the audience that we need bigger, broader, well-designed studies to really sort of draw any conclusions from this. It has been shown to have very potent antioxidant properties. So I would certainly encourage the audience to use just a pinch. All it takes is a pinch of turmeric in your food, in stews, soups, stir-fry dishes to get some of the benefits. So that's curcumin. Then there's vitamin E. We all know that's a very potent antioxidant. And about 2,000 international units of that in mild to moderate Alzheimer's disease has shown some modest benefits. Do you want me to keep going on? Just note some of the other nutrients that were used.
Maybe a couple more.
Folate, as the name implies, foliage, leafy green vegetables, orange juice, legumes. There was this landmark study, the Baltimore longitudinal study on aging. And in that, what that study demonstrated was that folate at or above the RDA was associated with a significantly reduced risk of Alzheimer's disease. And then let's not forget all the other antioxidants, the flavonols, anything with bright, vibrant colors. We know that the mark of an antioxidant is that it leaves a stain behind, and foods with those bright, rich colors have antioxidant properties. So in a 2000 study, what they saw was that a flavonol or antioxidant-rich diet can actually upregulate genes in your body that are associated with learning and cognitive function, and downregulate the genes that are associated with inflammation and learning deficits, which again should not be surprising given that oxidative stress reduces levels of neurotrophins. So anything with antioxidant properties that would mitigate that oxidative stress would then boost BDNF levels and promote neurogenesis. Last but not the least, intermittent fasting, which has become a hot topic these days, and calorie restriction have also shown some surprising benefits. They both actually boost BDNF levels. And the theory behind that is that while chronic stress releases cortisol, which is a stress hormone in the brain, killing those little neurons we were talking about that are part of neurogenesis and memory formation, the mild stress that is caused with calorie restriction actually has the opposite effect. It forces the brain to think and triggers neurogenesis, and all kinds of neuroprotective mechanisms are triggered. And so So those findings were, to me, that was was a little surprising that intermittent fasting actually helps.
I've done a little bit of reading and understanding about a little bit more about intermittent fasting. And I know one of the main things that happens is that your body stops producing insulin. So then your body is also basically doing some of those reparative things. Your body goes through some repair processes and starts using those kind of things that are out there just hanging out that it hasn't had the time to repair because it's so busy with insulin doing the storage and the energy use that it kind of lets your body calm down, which you mentioned, like you're saying it's a mild stress versus your body having to digest food, so that allowing it to go through that process.
The research shows that while basically there is an upregulation of receptors in the brain for stress hormones with chronic stress, and you don't see that with when you withhold calories or you go through intermittent fasting. And let's bear in mind that any excessive calorie consumption in and of itself will increase oxidative stress to the body. And then a whole cascade of reactions ensues that's unfavorable. But also the research showed that certain neuroprotective mechanisms are triggered. Stress proteins called heat shock proteins and glucose regulatory proteins are produced that have neuroprotective mechanisms, and also the ketones that are produced when someone undergoes fasting or a low carb diet, and fats are burned in the absence of carbohydrates. The incomplete oxidation of fats produces ketones, and ketones, it has been demonstrated that ketones also have neuroprotective effects. It's a whole sort of they can actually impact epigenetics in the body that would go beyond the scope of our discussion today. But suffice to say that intermittent fasting and calorie restricted diets did show favorable effects on BDNF levels.
You mentioned this a little bit, but vitamins. So you mentioned using antioxidants, and you mentioned some specific ones, and I know that food is definitely better to get because we just don't know all the properties that are helping our bodies. But are there vitamins that people might want to think about, or is it good to take some extra antioxidants in a vitamin to improve your brain power?
In this, the Baltimore study of aging, longitudinal study of aging that I was talking about, what they found, and basically they followed non-demented elderly volunteers for like 9.3 years. This is a pretty long study. And what they found was that higher intake of folate, vitamin E, and vitamin B6 were associated individually with a lower risk of Alzheimer's disease. But when the three vitamins were analyzed together, only folate at or above the RDA was associated with a significantly lower risk of Alzheimer's disease. So I hope that answers your question.
Yeah, I think it's good to always remember that food first. So getting those dark leafy greens and good sources of folate. We've also seen, I know this isn't the topic today, but when I was pregnant, definitely they want young women in their childbearing ages to do the folate and to get plenty of that DHA because of the neuro benefits.
Absolutely. So at the end of the day, we just want to remember that it's whole foods that count and not individual nutrients. And the best way I can describe that is, if you think about it's lovely to hear a violin playing. It sounds beautiful, but you don't get the full glorious effect until you hear the whole orchestra. And that's the same thing with food. Those vitamins and nutrients and whatnot are wonderful, but it's not until you eat whole foods that you can tap into the real power of all those foods. So that's one way of looking at it.
Kind of another thing you mentioned at the beginning was talking about exercise and going for a walk or whatever. So Can we dig in a little bit to how does exercise affect BDNF?
Yes, absolutely. So exercise is actually one of the most powerful ways of changing your brain and rewiring its chemistry. Exercise has been shown to increase BDNF levels. And in fact, there was a study that was done in which they found that in that particular study, exercise increased BDNF levels by as much as 32%. And we're talking about moderate intensity to exercise, engaging in exercise for about 30 to 40 minutes or so. And I also want to share this landmark study that was done in, I believe, 1999 at Duke University. And the investigators actually had the nerve to test exercise against Zoloft. And so they had these 3 cohorts of subjects. One cohort took Zoloft. The second cohort exercised 4 times a week for, I believe, a half hour. And the third cohort took Zoloft as well as exercise. And to their surprise, after 4 weeks, depression scores dropped to normal across all 3 groups. So then we had, the friends of big pharma, shall we say, the skeptics who said, hey, you didn't have a placebo. So they added a placebo and depression scores dropped to normal again across all 3 cohorts. So this was, again, groundbreaking research that really got the attention of the scientific community, and again, underscoring the role that exercise plays in this whole picture. One thing I forgot to mention, Mathea, is that a lot of the studies that were done on DHA, curcumin, vitamin E, they also investigated the role of exercise concurrently or simultaneously with these in rats. And what they found was exercise synergistically increased levels of BDNF. So the concurrent application of exercise, or exercise along with a wonderful healthy diet, clearly compounds the beneficial effects that we see from healthy foods.
So you're talking about any type of exercise, whether it's weight training or it's aerobic exercise, or is there one particular kind of mode that they've studied?
From what I can tell, and there's so many different studies on this, but from what I can tell, it seems to me that aerobic exercise appears to provide the greatest benefits, from what I can tell from the research. And there's a lot of, studies that have been done on this, from what I can tell.
So it really sounds like 30 to 40 minutes 3 or 4 times a week provides this increase in BDNF that helps with our memory and our brains.
Absolutely. You want to get your heart pumping and you want to get more oxygen to the brain. Really, that's what it's all about.
You mentioned the Western diet being the biggest issue that causes brain problems. What diet changes are recommended to improve how BDNF works in our brain? So we've talked about what not to eat, and a little bit I think we've touched on what to eat, but what diet changes are recommended to help improve that, and how long does it take before you start seeing changes?
Basically, a Mediterranean style diet that is high in fatty fish, or if you're a vegetarian, then tapping into omega-3 fatty acid sources through nuts, seeds. Some leafy greens also, by the way, have can provide some omega-3, fresh fruits and vegetables, whole grains. Whole grains actually do have antioxidants called lignans. So that's something we just want to bear in mind. Legumes, as well as, basically just whole and unprocessed foods that are a dietary pattern that is low in added sugars and refined sugars would have beneficial effects in terms of raising BDNF.
If somebody's starting to or wants to improve their memory, whether they feel like they have any sort of deficit or not, they feel like they could improve their memory. How long eating this way before they start seeing some changes?
So, Mathea, I just want to share with your audience some studies that were done in rats. I do want to just insert a word of caution. These were studies in animal models, not human beings, but the evidence is pretty compelling. And in separate trials, these rats were basically fed a high-fat diet, and then the poor little critters were subjected to a traumatic brain injury. So both of which causes oxidative stress. What they found was the set of rats that were supplemented with antioxidant-rich nutrients, curcumin, vitamin E, and DHA, they actually aced a spatial learning test. And the rats that were not supplemented with antioxidant-rich nutrients flunked the test. So this spatial learning test is called the Morris Water Maze. And what it is these little critters are made to run around an open swim area, and they are supposed to locate a submerged escape platform. So the rats that were supplemented with antioxidant-rich nutrients aced the test. The rats that were not supplemented flunked the test, which underscores the fact that antioxidant-rich foods can mitigate the oxidative stress created from a high-fat diet and from the traumatic brain injury, boost BDNF levels, and restore cognitive function. One other factor that I would like to mention at this point, Mathea, is that your diet actually causes structural and functional changes in the brain, which is pretty amazing. And this is why the hippocampus actually shrinks on a Western diet. This is also what we see with depression and schizophrenia, by the way. But the hippocampus actually shrinks.
That's, amazing to think that it's protective, because we never know at what point we might have more oxidative stress than others. So being preventative is definitely a good thing. And those studies you mentioned about rats were like 3 weeks or a month, or?
As I said, there were like separate trials with DHA, curcumin, and vitamin E, and some of them were 4 weeks, some of them were 8 weeks.
So we've talked about diet, we've talked about exercise. Are there other factors that affect BDNF in our brain?
Essentially, anything that we can do that challenges the brain is going to boost BDNF levels. It's so funny, but just using your brain actually increases BDNF. Any kind of visual and cognitive stimuli is going to increase BDNF in the brain. But it doesn't have to be cognitive. That's really what is so empowering about this. It could be learning a new skill, a new motor skill. So if you've never learned to ride a bike, if you do so, that's going to boost BDNF levels. Learning a new language can boost BDNF levels. Learning to play an instrument, that's going to boost BDNF levels. So anything that essentially challenges the brain can work in our favor. Meditation has been shown to increase BDNF levels. Getting a full night's sleep increases BDNF levels. Also, enrich social environments. So having those meaningful relationships with the people around you, having meaningful social connections, social circles, and so forth, friendships, all of this has been shown to have a favorable effect on BDNF.
I remember when I was growing up, my grandmother, she refused to use a calculator to balance her checkbook. And she was convinced that helped her to keep her brain, healthy. And what you're saying is that she was right.
She was, because unbeknownst to her, she was using the fundamental rule of neuroplasticity. If you don't use it, you lose it.
Absolutely. And I believe she actually said that. She didn't say the neuroplasticity part, but she said, if I don't keep using my brain, I'm going to lose this ability.
Well, in her infinite wisdom, she knew what she was doing.
My grandmother has lots of things like that. Yeah. You've made me actually just hopeful that, our brains don't deteriorate if we take an active part and we eat healthy and we exercise, which is normal, healthy recommendations anyway, that we can, have that brain power well into our
old age.
Yes, It's the quality, not the quantity. So you can have a quality of life. You're improving the quality of life.
And with simple things that are already at your fingertips. The foods that we are talking about they are probably already in your kitchen cabinet.
Yeah, you just have to make that effort to eat them and on a regular basis and keep those, not to say sugar and everything is the worst thing in the world, but definitely keep that at a minimum. Yeah. So tell me a little bit about listeners who've listened to this whole podcast are thinking, gosh, this is great. I should eat healthy or whatever. But how can they use it in their day-to-day life, especially if they're like a clinician and they're working with people on a regular basis to help them, not necessarily for their brain power, but just eat healthier and stuff?
Are you talking about just the lay consumers? Or I just want to make sure.
I think lay consumers is one, and then clinicians is another. So can you talk a little bit about how they may be different? They may use it in their life?
Again, back to some of the basics that we discussed. Your behavior is actually the biggest driver of neuroplasticity. Think about things that you can do that would challenge your brain. Nurture behaviors that lead to positive changes. We talked a lot about neuroplasticity and developing good habits, and try to give up those behaviors that don't create positive changes and watch that neural pathway disappear. So for instance, think about things that you can do that would favorably impact your brain. And it could be, little things. It could be perhaps maybe if you're drinking, soda or something like that, and gradually cutting back on that, carving out a new neural pathway, which initially might seem awkward, but as you keep practicing it, the old pathway disappears, and before you know it, you've changed that habit. Think of things that you can do in your day-to-day life that would help create favorable changes in your brain and boost BDNF levels. Back to, whole foods, unprocessed foods. Use spices. Spices in your cooking, spices have potent antioxidant potential. And I had mentioned turmeric earlier. Just a pinch goes a long way, and you can use it in stews and soups and stir-fry dishes and whatnot. I do want to mention that it's very pungent, so all it takes is a pinch. You don't want to do more than that, and you can put it in practically every dish, except I warn you, dessert, because that dessert will no longer be dessert and it will turn into something savory. Little things that we can do, shooting baskets with your kids, riding a bike with your kids, maybe riding down a new path, and now you're killing two birds with one stone. Get the exercise, and you have challenged your brain by going down a new path, if you will. So anything that we can do that will help boost BDNF levels, and it's simple things that we can do in our day-to-day lives that will ultimately help improve and enhance cognitive function.
So that makes a lot of sense. And I would like to end the interview the way I always end it and ask you to tell me your favorite food.
My favorite food is a really decadent triple layer chocolate cake with homemade buttercream frosting, of course.
All right, Sangeeta, thank you so much for being on the podcast today. It was a pleasure to have you on the show. I know my listeners have learned a lot about BDNF and brain health and how to just keep your brains active and have a good quality of life. So if listeners want to connect with you, what's the best way to do that?
Listeners who want to connect with me can find me on Web Dietitian, WEB Dietitian.wordpress.com. And they can just click on the contact tab on the menu bar. And that's probably the best way of reaching me. If you Google Web Dietitian, it should pop up. And I have a Facebook page as well for Web Dietitian.
Okay. So, well, guys, this has been another great episode of the Nutrition Experts Podcast, the podcast that is all about learning more so you can do more with nutrition in your life.
You've just listened to an episode of the Nutrition Experts Podcast. Be sure to get more information about this week's episode at www.nutritionexpertspodcast.com. Tune in next time for another great conversation with a nutrition expert and expand your personal knowledge in the field of nutrition, one conversation at a time.